Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine running your hand over an old, worn leather book, or the rough grain of a wooden desk from your childhood classroom. In that instant, you don't just feel the texture. You smell the dust, hear the distant chatter, and feel a surge of emotion. This isn't coincidence. This is the asterisk friction memory asterisk, a powerful neurobiological phenomenon where tactile texture acts as a silent key, unlocking our most resilient and perfect memories. We usually think of memory as a visual or auditory experience. We recall faces, songs, or conversations. But the sense of touch, the haptic system, possesses a unique structural advantage in the brain that allows it to forge deep, almost unbreakable links to the hippocampus, the brain's central memory warehouse. So, how does this process work? It starts in the skin. Your hands are densely packed with specialized sensors called mechanoreceptors. You might know about Meissner corpuscles, which detect light touch and flutter, and Pacinian corpuscles, which register vibration and pressure. When you touch something, these receptors aren't just sending a generic touch signal. They are translating the physical properties of the material, its roughness, temperature, elasticity, and crucially, its asterisk friction asterisk, into distinct vibrational frequencies. When you slide your finger across a smooth sheet of glass, the signal frequency is low and uniform. When you touch coarse sandpaper or an aged piece of fabric, the friction generates high-frequency, complex vibrational patterns. These unique frequency profiles are what the brain registers as texture. They are, in essence, the data points of the haptic code. These coded signals travel rapidly up the peripheral nerves to the somatosensory cortex, a strip of tissue running across the top of your brain. This area contains a famous, distorted map of your body called the sensory homunculus. Every part of your body that can feel, especially the fingertips and lips, has a corresponding territory on this map. Here's where the power of friction memory separates itself from vision or hearing. The somatosensory cortex has unusually direct and close connections to the deeper limbic system, particularly the amygdala, our emotional center, and the hippocampus, where long-term memories are formed and retrieved. While a visual memory often needs to pass through several processing layers before hitting the emotional core, the tactile pathway is relatively immediate. This direct structural pathway means that haptic input is often intertwined with powerful emotional markers the moment the memory is laid down. If you felt excitement while holding a specific, rough wooden toy as a child, the high-frequency vibrational signature of that wood texture is neurologically tagged with excitement. Decades later, touching a similar texture doesn't just remind you of the toy. It reconstructs the original emotional state. Research has shown that this connection is so fundamental that infants prioritize haptic exploration, grasping, mouthing, and touching, to map their world before they master sight or language. These early haptic memories form the bedrock of spatial and self-awareness. This understanding of friction memory is revolutionizing product design and therapy. Take, for example, museum exhibits. Curators are increasingly incorporating touch tables with textured materials related to the exhibits. Students who handle geological samples or ancient textiles show significantly higher retention rates than those who only look at pictures, because the multi-sensory engagement cements the learning into the deeper emotional memory system. In the digital age, we suffer from haptic deprivation. Most of our interaction is mediated through slick, uniform glass screens. Our digital tools, designed for maximum smoothness and minimal friction, are optimized for speed but are structurally poor for generating the deep, complex frequency data needed to create resilient, friction-based memories. The homogeneity of the digital texture means we are unintentionally sacrificing the power of touch in how we learn and how we connect with the past. The friction memory serves as a profound reminder that touch is not just a passive sensor. It is an active, essential partner in cognitive mapping. It holds the oldest, quietest archives of our lives, waiting for the precise vibrational frequency to trigger perfect recall. For more incredible facts like this, don't forget to subscribe and turn on notifications.